Hi there, welcome to this month's technical training podcast from AMSES Training. In this podcast we're going to take a look at launchd, which was introduced with macOS 10.4. If you have any suggestions on future podcasts you would like to see, please feel free to email your ideas to podcasts@amses.co.uk. For a full list of Apple authorised training courses and other services, please feel free to visit our website at www.amses.co.uk. With macOS 10.4, Apple introduced a new system startup program called launchd. launchd performs two main tasks. The first is to handle system initialization as macOS 10 boots, and the second is to load and maintain daemons either on a startup or on demand as and when required for either the system as a whole or individual users. So historically, Unix has had various mechanisms for starting processes on boot as well as during normal system use. And it was the same situation for macOS 10. It was often very hard to work out which mechanism started which process, and to complicate things, each mechanism had a different method of being configured. With macOS 10.4, Apple decided to replace these mechanisms with a single unified program called launchd. Now, some of these mechanisms have been completely replaced by launchd. Others are still here to support legacy applications, but make no mistake, launchd is the future of macOS 10. So first of all, we're going to look at some of the mechanisms launchd is intending to either replace or supersede, which come into play during the boot sequence of macOS 10. Firstly, launchd is a replacement for init. Under 10.4, there is no init process. With previous versions of macOS 10, init was the root process of everything that ran, and it was also responsible for calling the RC scripts during boot. launchd now handles this function. launchd also has a process of ID of 1, as did the old init process. Secondly, launchd now starts some processes that used to be started from the /etc/rc scripts. These scripts are the traditional startup scripts used by Unix to perform initialization tasks as the system boots and to start some processes. These scripts are not the easiest to configure, and the slightest error will cause major problems for the system. These RC scripts are still used, but at some point in the future, Apple hope to phase them out. Thirdly, it is intended to be a replacement for the system starter process. System starter was introduced by Apple as a mechanism to start, stop and restart system services, which are described in either library startup items or system library startup items. System starter still exists for now, mainly to support legacy startup items. System starter was Apple's first attempt at a simpler, more user-friendly mechanism to start processes. Finally, launchd is intended as a replacement for Mac initd, which still exists. Mac initd is used to start key system services such as lookupd and configd. So as you can see, the number of different ways a process can be started really does complicate things. So with launchd, we supersede many ways of starting processes, each of which has a unique configuration file. The benefit is that we now have centralized control and management of these processes, as well as a unified configuration file format, which we'll take a look at later on. So here is a quick overview of the boot process that macOS 10 goes through. So first off, the boot ROM is activated. Boot ROM is the hardware component of the boot process, which includes the power on self-test and includes either open firmware for the PowerPC range of Macs or the new EFI for Intel machines. Assuming the power on self test has passed, control is then handed to bootx. The primary task of bootx is to load the kernel environment and the necessary kernel extensions such as drivers for the I/O buses for booting the system. It is at this point you should get the metallic apple drawn on the screen with the spinning gears. launchd is then started. launchd is given a process ID of 1. It executes the RC scripts in /etc, which in turn launches the system starter daemon to handle the old style startup items in either system library startup items or library startup items. Next, launchd scans through 2 directories looking for its own configuration files. These directories are system library launch daemons and library launch daemons. Each configuration file is a standard macOS X plist file which represents a process that launchd needs to manage. The contents of the plist file specifies the location of the code that should be run and when the process should be launched. Should it be launched on startup and remain persistent, or should it be launched on demand? We will look at these preference files later on. Finally, launchd starts the login window process, which prompts the user to log into the system. So in order for launchd to manage a daemon, a config file must exist for each one. These config files come from 2 locations. The first is system library launch daemons, which are system-wide daemons that were installed with the OS. Or secondly, library launch daemons, which are system-wide daemons installed by the administrator. Daemons that are run from here run as the root user and do not require a GUI. So examples would be the daemons that manage SSH and FTP. launchd can also manage something called launch agents. These are located in the following directories. You have one location of system library launch agents. These are system-wide agents installed with the OS. The second is library launch agents, which are system-wide agents installed by the administrator. And then finally, we have a library launch agents directory in the user's home folder, which are user-specific agents. Launch agents are very similar to launch daemons, except for 2 major differences. The first is that they run under the context of the logged-in user rather than root. And secondly, they can show a GUI. Importantly, launch agents only run after a user logs in, unlike launch daemons that can be loaded during boot. Rather than having daemons start on boot and remain persistent, with launchd we can have daemons that only start up when requested and then shut down when the request is finished. This is called on demand. launchd can also listen to network connections and start a required process if a connection is made to a specific port. On demand gives us a number of benefits. Firstly, we have faster boot times, as the system does not need to start all processes at that point. This is one of the reasons why macOS 10.4 boots a lot faster than previous versions of macOS 10. It also frees up memory and resources, as we only have processes running that are required for that point in time. Examples of on-demand launching are the SSHD daemon and cronD. SSHD is the secure shell daemon. This daemon is only required when port 22 is contacted by an SSH client. Another example is the cronD daemon. This historically has been used to schedule tasks to run at specific times and intervals. cronD is only needed when there is a cron tab file, the cron tab file being the configuration file for cron. So cronD only runs when launchd detects a cron tab file. We will look at cron and scheduling in more depth later on. For these two examples, we can see that different events can trigger an on-demand launch of a daemon. Similar to Watchdog, launchd can monitor daemons to make sure that they are kept running. So if you have a service that crashes, launchd will attempt to restart it. So I'm just going to demonstrate on-demand launching in action. So what I'm going to do is first of all just run activity monitor, and I'm just going to check that launchd is currently running by filtering out the results just for launchd. And notice launchd is currently running and it's got a process ID of 1. I'm now going to filter for the SSH daemon, which is currently not running. So I'm going to go to my sharing preferences and turn remote login on. And still SSHD is currently not running. I now bring the terminal up. I'm going to just do an SSH connection to my server. And as soon as I hit enter, launchd launches the SSH daemons. I'm now going to quit the client by typing no to close the connection, and launchd now closes or quits the SSH daemon services. I'm now going to filter for the FTP daemons, which again is not currently running. I'm going to turn the FTP service on. I'm now going to do a connection via my client to my FTP server, and as soon as I hit enter, launchd launches the FTP daemons. And as soon as I quit the client, it closes off the daemons. So now we're going to take a look at the launchd config files. Property lists, also known as plist files, are the chosen format for launchd config files. For each daemon launchd handles, there must be a corresponding plist file. Regarding naming conventions, Apple prefers you use a reverse domain naming scheme for the name of your config file, but you don't have to. As an example, com.amsys.mydaemon.plist. There are many ways to view these files as well as to create your own. Because plist files are just text files, you could use a plain text editor such as TextEdit or Nano in the command line, or you could use a plist editor such as Apple's property list editor that you can get free with the Apple developer tools. Another option is to use a third-party tool such as launchd editor from Code Poetry or Lingon from Peter Borg. So we'll first have a look at one of these existing config files in both a text editor and also in Code Poetry's launchd editor, just to see a comparison. Okay, so we're first going to look at some example launchd configuration files that Apple supply. I'm looking in the system library launch daemons directory. As you can see, there's quite a few in here. There's one for FTP, there's one for the login process, there's one for SSH. There's quite a few, and each one of these represents a specific daemon to launch. So firstly, if we look at the one for FTP, we're going to first open this up into a text editor to see the raw XML file. So here's our FTP config file. So it looks very similar, or very much like a standard plist file. At the top we have the normal XML headers you would expect for this sort of file, and below this we have the information for launchd. The first option is the label. This is the label that, or the name that launchd will use internally to reference this specific daemon. And again, notice it's in reverse naming kind of order. So in this example, it's com.apple.ftpd. The next section, program, basically tells launchd exactly where on the file system it can find that specific program. So in this example, it's in /usr/libx. And in program arguments, just tells launchd if that specific daemon needs any parameters passed to it when you launch it. And in this example, it's obviously passing the -l parameter. Some services can use things like bonjour to advertise themselves. So the sockets section just tells launchd that, or will tell launchd which kind of networking service it will use. So as you can see in this example, bonjour is set to true. Okay, so it's very much like a plist file. If we open up the same file into launchd editor, we get a much more friendly view of the file. This is obviously much more friendly now. So here's our label, com.apple.ftpd. Okay, here's the path to the program. So /user/libx/ftpd, and then they're the parameters that we're getting passed to that daemon when you launch it. And the sockets, obviously, this is where bonjour was enabled for that service. And also in here it tells you what version of IP, etc. the daemon uses. So these GUI editors are much more simpler to use than the raw text files. If we look at Telnet, slightly different one. Here's Telnet. So again, very similar to the FTP one. We've got the same sort of parameters. So here's our label. Again, this must be a unique name for this specific service. So this is com.apple.telnetd. There's the program arguments, and it's just telling launchd exactly where on the file system it can find the daemons. Now this one's slightly different. At the top we have a disabled section which is set to true, and this basically tells launchd that this specific daemon is not currently being used, it's actually disabled. So if we open that one up into launchd editor now, again we can see this. So here's the label, com.apple.telnetd. There's the actual path to the program, and if you go to configuration, there's a checkbox for disabled. So if you tick that, that would basically disable that specific daemon. Okay, so for the next demonstration, we're going to create a simple launchd config file. As a quick demonstration, I'm going to create one that launches TextEdit. Now, because TextEdit is a GUI app, it must be a launch agent, because remember, launch daemons can't display a GUI. However, the config files for launch daemons and agents are the same. So using launchd editor, I'm going to create a new config file. Okay. So first of all, I need to give it a unique label. So using the reverse naming scheme, I'm going to call this com.amsys.textedit. Okay. I then need to specify the path to the program. There's my path. Now this looks slightly unusual. Remember, GUI apps are basically presented, are basically packages or directories that look like a single double-clickable application icon. So for the path, I need to specify the actual binary within the main package. So in this example, TextEdit, which is in the package textedit.app. Having done this, for startup, I'm going to basically make it launch as soon as the config file is loaded, with an interval of 2 seconds. So it's going to launch TextEdit 2 seconds after the config file has been loaded by launchd. I'll then go to Save As, and I'm going to save this into my home folder, into Library, and into Launch Agents. Okay, and again I'll give this file a name, so it's com.amsys.textedit, and I'll hit Save. And that's now saved the file. If I open this file up into a text editor, okay, There's my file. It's been created. You can see it's created all the XML code for it. Now, as soon as I kind of log out and log back in again, TextEdit should automatically launch. Okay, so I've now logged out the system and logged back in, and launchd has now launched TextEdit by picking up that config file we just created. One interesting thing we mentioned earlier on was the ability of launchd to restart services that it thinks have crashed or quit. So if I now quit TextEdit, launchd actually relaunches it again, and it'll keep doing this for a period up to about 10 attempts. After about 10 attempts it gives up, assuming the application can no longer run. So let's now look at how you can schedule daemons to run at specific times. There's been a lot of misinformation regarding cron and macOS 10.4. Cron is the historical daemon used to schedule tasks on Unix. Cron is still available on macOS 10 as an option to use. It's just that it's disabled by default. As soon as launchd finds a cron tab file, this being the configuration file for cron, it will launch the cron daemon. All your existing cron schedules should then work as they did in previous versions of macOS 10. For new schedules, it is advisable to use the scheduling features of launchd. macOS 10.4 comes with 3 examples of schedule scripts that you can look at. These are the Unix maintenance scripts that, among other things, are used to clean up a variety of system logs and temporary files on your hard drive. These can be found in System Library Launch Daemons. As you can see from their names, one is run daily, one is run once a week, and then the third one is run once a month. Right, let's look at some of these sample files. Here's the daily one first of all, and this is in System Library Launch Daemons. So if I open up the file into launchd editor, just for ease of use. Okay, first of all, you can see that it's got the normal options for standard launchd config file. We have the label up here. Okay, this is the actual daemon which launchd will run. It's a program called periodic, which is used to run scheduled tasks. And the arguments, we're basically passing the daily argument to periodic. Now daily represents a shell script called daily, which is in the etc folder, and you can see this this shell script. So periodic will actually execute the daily shell script, and this script is basically responsible for doing all the housekeeping. Under startup, this is where we can set the time of when the launchd runs this config file. And as you can see, it's set to run at 3:15 every morning. This is probably an example where you may want to change the time, because if your machine is not switched on at this time in the morning, launchd won't run these commands. If we look at the other one called weekly, okay, again, same sort of thing. It's got a label at top. It's the same periodic command it's going to run. And this time we pass in the weekly shell script to it. If we go to startup, again this one runs at 3:15 in the morning, but it runs on weekday number 6. Now weekday number 6 is actually Saturday. Basically the numbering scheme is 0 for Sunday, 1 for Monday, 2 for Tuesday, etc. So this script will run at 3:15 every Saturday morning. And then the final one is monthly. Okay, so again, same thing. It's got a label. It's the periodic command, and it's passing the monthly shell script to it. If you go to startup, this one is now running at 5:30 in the morning on the first day of the month. So by using this feature, we can schedule any launchd config file to run at any time we choose to. And finally, we'll have a quick look at a command line tool called launchctl. launchctl is a tool that allows you to interface with launchd and basically control what it does. It has a number of uses. The most common are to list the currently active configuration files that launchd is managing, and then you can use it to either manually unload or load configuration files on the fly rather than having to restart the system. Okay, let's see launchctl in action. So the first thing I can do is just type in launchctl list, and that will list the running config files that launchd is managing. Now notice that I've only got one, which is the text edit example I created earlier on. Okay. However, if I sudo the same command, I get quite a few more back. Why? Well, remember the text edit one was a launch agent, and that ran under the specific user context that was logged in at that point. So if we run up Activity Monitor, we currently now have two versions of launchd. We've got launchd with a process ID of 1, and the user context is root. This is the launchd that was launched during the boot sequence and handles all the launch daemons. Remembering launch daemons run under the root context. Because I created a launch agent, that creates a second instance of launchd that runs under that user context. In this example, the administrator account. And this is basically a security reason why they do this. Okay. So just remember that if you want to see the system daemons that are running, you have to sudo the launchctl command. Okay, the next thing we can do is, if I do launchctl again and list the user ones, I can actually unload that running configuration file. I can type launchctl space unload space, and then I put the path to the config file we created. So if I just drag one in, so it's putting in the absolute path to that configuration file that I created in my home directory. If I hit enter on that, that now unloads that configuration file. So if I relist that now, the configuration file has been unloaded. And likewise, I can actually manually load that file up myself. So I can, if I just drag this back in again and hit enter, okay, and then do a listing again, that config file is now running. For more information on launchctl, just type man launchctl in the command line and you'll get the man pages back. Well, we really hope you found this podcast on launchd really useful and a good starting point. And stay tuned for future podcasts from AMSES. Bye bye.